Right, good morning everybody. Today I want to talk about the standard error of the regression and how we get the standard deviations of or the standard errors of the various estimated coefficients, particularly the slope coefficient is what I am interested in. I will also explain how you get your R squared and by deduction the F statistic. So now this is a sample of 50 people in the labor market. We are told the levels of their earnings and the levels of their education. So we're going to estimate this regression here. Let me remove everything that is here. Okay, so we pick our Y values, which is your earnings there. Then you come here, you pick your X, which is your education. The data includes labels. Now I want us to generate the residuals, that is the predicted error terms, error observations. So let's tick this one for now and we say okay. The regression that is generated for us is this we see here. Let me just reduce these things to 2 decimal places for neatness. Maybe 3 to 3 decimal places. I don't need these automatically generated confidence intervals yet. So what it has done is it has estimated the output for you and reported main statistics, and because we said it must generate residual output, it has generated the predicted earnings here and also the residuals, predicted residuals. But I want us to do that manually so that you can understand where that is coming from. Now, so our regression is this. So let's have it. Let's bring that stuff here. I'll just paste these two things here, that is the intercept and the slope coefficient, so that you can understand what I'm talking about. Right, so now let us proceed and say what is our predicted earnings. In other words, to say it's predicted means it's being predicted from our regression. Our regression has this constant here, or intercept, minus 3.402 plus this slope coefficient here times a value of y. Now, because we will use these same two values for all the observations, we have to fix them. So let's use the dollar sign is used to fix values, because if you don't do that, it will end up calculating things using blank cells below them. So every time we do this, as we go down, it will still pick these two values and multiply by the respective value of x. Okay, value of education. Then you say okay. So this is what our model predicts. This is the actual level of earnings that were reported by our participants in the survey. So we can double click, it will generate everything for us. That's your predicted earnings. Now your residuals are equal to your earnings minus predicted earnings. Okay, that's what we mean by residuals. Okay, so if we take this part beta 0 plus beta 1 education, if we take it to the other side, this, once we have found these two numbers, it's your predicted earnings. So whatever remains here is your predicted error, which we call the residuals. So this is equals to that minus that, and you ask it to reproduce everything, right? So we can then square the residuals squared, which is this number here, squared, and we ask you to do the same for all the values. Now, so we can now generate the residual sum of squares. That is, we are now finding the sum of all these numbers we just squared. Now sum, we want the sum of all these, right up there, and this is what we get, 752.51. Now if you come to your regression, you will see that this is the number you see here. That's your residual sum of squares. Residual sum of squares is 752.2135. That's the number we have. Just because of rounding off, we have 0.21 whatever. If I were to increase this to 4 decimal places, you see it's 0.2135, which is exactly what you have there. Okay, now the variance of the error term, because we can't observe the population variance of the error term, what we often do is we estimate it, and econometricians have shown that generally in large samples the value of the variance you estimate using the residuals is not that biased. So this is equal to residuals. So this is equal to residuals sum of squares divided by n minus k. That's the formula you use to find the variance of the error term. Now, where k is the number of coefficients estimated in the regression. So here we have the intercept and the slope coefficient. So our k is 2 in this case. So we are actually saying RSS over n minus 2. So if you have a 3-variable regression where maybe there's also experience, so that you have beta 2 experience, you now have 3 coefficients, then here you will put 3. Okay, so that's the formula. What do we get? So we now say this is equal to that, okay, divided by, we have 50 people in our sample and we estimated 2 coefficients. You close, your answer is 15.671. so what is the standard error of the regression, bearing in mind that the variance of earnings will be equal to the variance of error term. Okay, in other words, what we are saying is the variance of the dependent variable is always equal to the variance of the error term. So therefore, the standard error of the regression is actually equal to the standard error of your dependent variable, and this is equal to the standard error of the error term. Okay, and this is equal to, obviously now it's equal to the square root SQRT, that's the square root of that number there, the variance, and we get 3.958. Now let me copy all this. Yeah, I hope it won't change things. I'll paste that here. Well, now things have changed. What if I paste them as values? Okay, yeah, I've pasted them as values. Now I want you to observe something here, very important. Observe something here. So this is the standard error of the regression, which is also the standard error of our error term. Notice that it is this one reported here. That's the standard error of the regression. Okay, very important to understand that. Very important to understand that. The standard error of the regression. So this is a very important result. If we know the variance of the error term, then we know the variance of y. The particular reason why it's like that, it's because if your earnings, which I just call EN, is equal to your B0 plus B1 education plus error term, which is a random variable, if we take the variance of earnings, which will be equal to the variance of B0 plus the variance of B1 education plus the variance of the error term. What you know from this is that the variance of a constant is 0. So this number here is 0 because this is a constant. But because in repeated sampling the values of ED are fixed, it actually means that this entire component here is also a constant, also its variance is 0. So we actually have var n is equal to 0 plus 0 plus var error term. Of course, we know that the variance of error term is always sigma squared. Okay, so that's it. So once you know the variance of the error term, you can also deduce the standard error of the regression, which is this one. And it is this particular standard error that we are using to find these standard errors here for our slope and our intercept terms. So our intercept coefficient. So let me stop here for now, and then I'll proceed to talk about how you get the variance of your slope coefficient. Particularly, that's what I'm more interested in discussing here.